Hi friends, let's review real quickly all of the landforms that can be found at all the plate boundaries. So we're going to start with looking at the two types of crust. There are two types of crust, or two types of plates that are on Earth. There's continental crust, which is land, and oceanic crust, which is crust at the bottom of the seafloor, or is the seafloor. It's at the bottom of the ocean. They're mostly different, but the things that they have in common is that they can both be found on tectonic plates. They're both made of solid material, and they are both part of the Earth's crust. But continental crust is less dense and it's older. It's also much, much thicker, and it's made of granite. Whereas oceanic crust is newer, younger crust. It's more dense, and the way I like to think about it is I imagine it being like soaked with water, which would make it more dense. It's not as thick as continental crust, and it's made of mostly basalt. So these types of crusts, how they interact will result in different landforms. Let's look at that. There are three types of boundaries. The first one that we're going to look at is convergent boundaries. There's two types of motions that can happen at a convergent boundary, but in general, it is when they move towards each other. So they either move towards each other, just like this, and they move up, they push each other up, or based on the density of the crust and the plate, one will move below the other. They're still moving towards each other though. So first kind of convergent boundary that we find is between a continental and a continental crust or plate, so two land plates. When this happens, they're usually the same density, and because they're the same density, it means one is not going to go below the other. Instead, they're going to push against each other and cause an uplift of the crust, which results in folded mountains or non-volcanic mountains. When we have continental crust and oceanic crust meeting, we get volcanic activity. And we get volcanic activity because it involves plates or crusts of different densities. The more dense crust is going to move beneath the less dense crust, which is usually the continental crust here. Well, when we have this type of interaction. So the oceanic crust, being more dense, will sink below the continental crust. The crust will melt, and it'll create a region of really intense pressure that has to be released. It's released in the form of volcano. But because this is a continental crust, we'll get volcanoes along the coastline. So mountain ranges that are volcanic and trenches off the coast. So where these two plates meet, it creates a trench or like a really steep drop off in the ocean. When we have two oceanic plates meeting, two oceanic crusts meeting, we get the same kind of thing, except it's out in the middle of the ocean. So we still get a trench here, and where the plate moves below, the more dense plate sinks below and melts, we still get that hot pocket here of magma that is released, but instead of the volcanoes being on a continent, they're in the middle of the ocean and they create a volcanic island arc or just volcanic islands. These regions right here where the plate moves below, the more dense plate moves below the less dense plate is called a subduction zone. It's because to subduct means to go below, and the more dense plate subducts below the less dense plate. Second kind of boundary is a divergent boundary. Divergent means to move away from. So at these boundaries, the plates move away from each other. When it's two continental plates, meaning they're both land plates, it can create rift valleys or rift zones. And this is where the land is moving away from each other, which is causing a sinkage in the middle, which eventually, over a long period of time, can create new ocean basins because seawater is allowed to flow in and we get new oceans. This is going to happen in Africa eventually, in like a long time, like 30 million years. In the middle of the ocean, when we have two oceanic plates diverging from each other, we get mid-ocean ridges and seafloor spreading. This is really important for plate tectonics because this is where new crust is formed. So what happens is the convection currents move these plates away from each other, but as they move away from each other, magma from the mantle seeps up. It reaches a cooler area, it hardens, And because the convection current is moving this plate away, it hardens and moves away. So that's why we now know that the crust here is younger than the crust over here. The last kind of boundary that we're going to look at is a transform boundary. Transform boundaries are fun. They only occur on land, continental and continental plates, or that's at least the only place that we can really see them. So when two continental plates transform, they are sliding past each other. So notice, I didn't point that out. Notice how this plate is moving this way, this plate is moving this way. They're slipping and sliding past each other. When they do this, what really happens is that they're pushing against each other and they're creating a lot of pressure. And when one finally slips, it creates a vibration and it creates a crack in the crust. And the crack is called the fault line, but the vibration is called the earthquake. Earthquakes can happen at all of the boundaries, but they are most common and they are most destructive at transform boundaries. So that is all of the boundaries, 3 boundaries: transform, divergent, convergent, and all of the landforms that can be created at each. If you have any questions, message me or talk to me in class.